Okay. Just a moment. Yeah. Can everybody see the slides?
Yes,
Hello?
sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So
Yes.
before I start, just let me give you a brief introduction what we are going to discuss today. I've made some extra slides about the gate analysis. Okay. So this will cover briefly the important, or rather the salient features of the gate analysis, but the very basic part. Okay. Hello. Can you please mute? Can you please mute yourself? There is background sound. Yeah. And now this is the first steps towards learning the subject biomechanics, and gate analysis is of vital importance in the understanding of this subject. Okay, because we are going to deal with movement science. Now, I have prepared a brief lecture about that based on GAN course. Okay, GIAN. Perhaps you all know that this started in 2015, and myself with my collaborator, Professor Nico Valenskot of Netherlands. We had, hello, Nico Valenskot of Netherlands have been the primary contributor in the GAN course. And in fact, it was the first GAN course in India, okay, on orthopedic biomechanics for 2 weeks, end of 2015, December 2015. So there were interesting lectures, one of which is on gate analysis. What you have to do is, based on my presentation, I have given the website, the YouTube link, where you will get the lectures on day 4. But the first lecture is on the gate analysis by Nico Valenskot. And there are quite a few videos associated with that lecture. So the lecture is about half an hour, but when you listen to the lecture, you get to know quite a few things more than what I have discussed, what I will discuss in the in today's lecture. Okay, is that correct?
Yes, sir.
Do you all follow what I said? Yeah. So that link to the lecture is given already in this presentation. So everybody will have it. I will upload the presentation as well, as I did in earlier case. So let me go back to the presentation and start presenting. Okay. So I continue from where I left. So this is a more specific lecture on gate analysis. Now, everybody knows what is walking, and we all actually undergo this activity in everyday life. It's the most basic activity a kid actually learns when he grows up, he or she grows up. So walking can be defined as movement of the feet without falling down. Okay? Never having both feet off the ground at any instant. Okay? Or it can be defined as a cyclic, continuous set of ground reaction forces alternating from one foot to the other while moving in a direction. So it is a sort of a bipedal movement, okay, where there are 2 feet and they are taking part in this activity, a very basic activity which appears to be pretty simple but quite difficult to understand and mimic. Okay, for disabled persons with affected by severe sort of diseases like cerebral palsy or stroke or different deformities, for them even undertaking this sort of physiological activity becomes a obstacle in life. Okay, but not only human beings, but also insects, lizard, and many animals, they also go through this walking cycle or the gait cycle. Now, as I had shown this slide earlier, I think there were certain confusions regarding, let me just check, no chat, so everybody could follow. So there are certain confusions regarding understanding the gait cycle. So when you try to understand gait cycle, you have to concentrate on one foot, okay, the right foot or the left foot, okay. So first, if we consider a gait cycle, because there is a lag between the right foot and the left foot, okay, and we should, as it has shown on 2 bars, we have a left foot and a right foot. So if I consider the right foot, which is black here in this presentation, just a moment, pointer option, let me go to laser pointer. So this is the black foot, okay, or the right foot on which we will be concentrating. And you can see that the heel of the right foot is making contact with the ground. So I go to right, I start with the right heel strike or right heel contact, okay. The next important instant of the gait cycle is the foot flat, okay. After that, it is mid stance. Then you can see already that the heel is trying to take off, okay. It's starting to take off, has not totally taken off, but it is started to take off. And then the toe comes off the ground. So if we concentrate on the right foot only, this one starting from heel strike to toe off actually constitute the stance phase. Okay. The next major phase that follows the stance phase for the right leg is the swing phase, where the right leg is swinging in the air. Okay. So from toe off, it is the mid swing where it is swinging in the air at the mid phase. And then finally, you can see that it touches the ground again at heel strike. It strikes the ground at heel strike or right heel contact. So from right heel contact to the right heel contact is a complete one cycle, which is represented here. In the meantime, when this right foot is executing certain stance or swing phases, the left foot is also doing something at the same time, simultaneously. But it does something when the right foot is doing a swing phase, it is actually going through, when the right foot is going through the stance phase, the left foot is going through the swing phase. Okay, just the other thing. So if I try to characterize the gait cycle in terms of percentage, you can see here in the next slide, I have revised this slide for better understanding. So when the right stance phase is being executed by the right leg, the left swing phase is being executed by the left leg. Okay, whereas when the right swing phase is executed by the right leg, the left is executing the stance phase. But if you see in terms of percentage of cycle, the stance phase, be it right or be it left, is always 60% of the cycle. And within this stance phase, be it right or left, there is double support, where both legs are touching the ground at the same time. Then there is single support, either left or right, and there it is followed by a double support. Okay, so if you look into this figure, but try to read the figure first from the point of view of one leg, so either right or left, then it will be much more clearer to you. Now, how do we characterize this apparently simple yet complex movement of human body? So, in order to characterize, we need to measure some certain parameters. Okay, so there are important parameters, the step time parameters. There are time parameters, step time, double support time, stride, and there are step parameters, step length, stride length, and step weight. So these are all these things you can find in the video lecture, okay, of the GAN course. And you can also, apart from the video lecture, you're free to search in the internet basically anything on the gait analysis. But we are restricting ourselves first towards the basic understanding and measurement of gait analysis or movement analysis. This is the step one towards understanding biomechanics of movement science. Now, the next other thing is kinematics, okay? Position, velocity, acceleration in the spatial coordinate system. The next thing that comes is the dynamics, forces and moments that is occurring within the walking cycle or the gait cycle. Apart from these, we also actually quantify energy, the mechanical work and energy, or the metabolic energy that can also be measured. So all these things can be measured, and there can be various complex calculations related to the gait, characterizing gait cycle. Now, there have been several, techniques to measure movements. Okay, over the years, over centuries, and with evolution of technology, the measurement techniques have become more and more precise. So I just mentioned some of the techniques, like goniometers have been used in 2D and 3D measurement of joint angles, okay? But goniometers are not too much in use today because there has been a new, it has been not new, but quite an established method in form of reflective markers or optical markers. So it started with measuring displacement. The optical markers you can see already in the figure, where there are markers, fluorescent markers that are actually fixed on several parts of the body to actually measure movement of these points. We can consider these markers as points, and we measure the movement of these points during a physiological activity. So photography, very early days, photography was used to actually study human movements. There have been accelerometers which measures acceleration, velocity. As you all know, it is used in mechanical engineering to pick up, vibration. So accelerometers have been also used to measure human movement, stereosonic and electromagnetic. But these are mostly obsolete. The very, very important method that stayed and is still being used with, of course, minor modifications with advancement of imaging techniques as well as the computational power, optical methods have established itself in all over the world for measurement of movements. Now, 3D motion analysis is a very interesting topic. These topics are itself big research areas. So you are entering into the real biomechanics world, and you will be fascinated to know that how these techniques are employed in measurements of movement science. For example, you all know that in cricket, so I think most of the boys and even girls, they also play cricket. They have basic knowledge of cricket, and we come across many bowlers who actually use, in a tricky way, they use the tricky technique to bowl, illegal deliveries. Okay, so these illegal deliveries are, illegal way of bowling, or can be analyzed using this motion analysis system. Okay, so let me just elaborate a little bit, and then you will understand how these reflective markers along with a set of cameras are used in a lab to record or capture 3D motion and further analyze it for different requirements. So in this slide, you can see a person walking over two force platforms, two force plates or platforms. These force platforms actually give you as output ground reaction forces at many instants within the walking cycle or activity. You can see also markers, the optical reflective markers, the black points. So these are fixed on temporarily, of course, on the human body, and these are points that represent the lower segment of the body. Okay. There are also EMG sensors which can directly measure the muscle forces. Okay. There is a set of cameras. Okay. The more the number of cameras, the better will be the accuracy of the data acquisition system. Now we need about at least 3 to 5 preferably 5 cameras to record motion, but as you can see, it can go to 7, it can go to 9. So there is a set of infrared cameras which are actually trying to track the motion of the markers. So the markers are the key that define a segment of a body, and then using the computers and the software, we can analyze the movement of the markers. A typical example, as in the real world, you can see yourself that there are markers on the feet, on the ankle, on the tibia, and then at the knee joint. Also, there are similarly, as we move from the lower part of the body towards the higher up towards the upper segment of the body, there are more markers as well. Now, what is actually done is connect these markers or points by rigid links. And then we can actually forget about the body. It's represented by a set of links. So it actually is treated as a linkage system. So the kinematics, all the principles of kinematics applied to a linkage system can be applied to this human body as well. Also, please notice that there are two force platforms. Okay, so the person who is hitting the ground here you can see, as I am pointing from the laser pointer, so left leg is at the heel strike. Okay, whereas the right leg is toe off. Okay, so there are, in series there is force platforms which are measuring the gait in subsequent instances. So as I was telling you, the contribution of the force platform, which gives us data on ground reaction forces, which is very, very important, because that is one force based on which you can start doing your calculation. You need certain data to start calculating and calculating the unknown data. Okay, so the ground reaction forces are vital in the measurement, which is actually an output of the force platform. So on the left, you can see the graph which shows the variation of the ground reaction forces during a walking cycle. In the y-axis, it's normalized force. So it is normalized, the force, the vertical component, of course, only the vertical component is plotted, and that is plotted with respect to your body weight. Okay, so that is the reason why it is called normalized force. And you can see here similar nature of the ground reaction forces, starting from heel strike to toe off. So that is, so, and just this toe off means it is almost end of the gait cycle, because the next instant would be heel strike again. So you already see that how the ground reaction force, please notice this very carefully, that the ground reaction force is shifting from the heel slowly towards right, towards the toe. Okay, please note, because we will be actually analyzing the forces a little bit later. Now we move to the forces and moments. Now, you can see, when we are in a pure standing posture, standing straight, okay, that is the position that is represented on the right. So there is a ground reaction force. In this configuration, the ground reaction force vector is passing through the joint centers. So through the ankle joint center, through the knee joint center, to the hip joint center. Okay? So in a standing posture or position, the forces and moments in the body are all in equilibrium, static equilibrium. Okay? The moment or the instant we disturb that equilibrium position by executing some specific movement, okay, as you can see here, an example on the left is squatting. We are bending the knee. Okay, we are lowering the body, bending the knee. Obviously, the ground reaction force doesn't pass through the joint centers anymore. Okay, it is already taking a different path, which is indicated by the pink arrow. And this deviation results in creating some external moments in the body, which is counteracted. These external moments needs to be counteracted to maintain equilibrium. So it is being counteracted by moments offered by the muscle forces. Okay? So the lever arm has an important role to play on the external net joint load. So you can see here that this is the standing posture on the right, where the joint reaction force is passing through the joint center. So there is hardly any net moment created. But as you move to the left, from the left to the right, as you start moving, I am actually starting from a squatting position, and these green lines are actually the lever arm or the moment arm. So at a particular squatting position, you can see that these lever arms are contributing towards generating an external moment, which is counteracted by the moments produced by the muscle forces. Okay? Now let us consider the moment generation in an ankle, for example. Okay, so this is typically an ankle, and if we consider an instant, say toe off, so that at that instant the ground reaction force is passing through the toe. Okay, now this ground reaction force will produce an anti-clockwise moment about the joint center. Anti-clockwise moment about the joint center. Okay, which needs to be counteracted by the by the muscle force. You see the muscle force here, and this muscle force should act and create a counteractive moment in the clockwise direction. So the muscle force multiplied by the perpendicular distance d should be equal to the ground reaction force multiplied by the distance through which it acts. So this is the equation of the moment balance. Now, if we consider different instances, as you can now see, but try to concentrate on the graph here. So this graph corresponds to the different instances within the gait cycle, about the moments created during the gait cycle. It has a negative moment to start with and goes to a peak maximum moment, but which is positive. Now, how does this occur? So I will plot, say, for example, 3 instances. You can see here. So when it is actually heel strike, the joint reaction force, GRF, passes through the heel. Okay, so that produces a clockwise moment. And this is where it is negative because of the sign, because of the direction. When you move more towards the center, you can see this moment becomes 0 because the more towards the foot flat, the ground reaction force is aligned more through the joint center of the ankle joint. So the net moment becomes 0. But as you move towards the right, so this position of the joint reaction force is shifted more towards 2D, and that produces a very high positive moment, which needs to be counteracted by the muscle forces. So this is how the progression of the moment generated within the ankle is exhibited. Now, the picture on the right summarizes that there is a lot of mechanics in human movement, okay? And I have spent some time in finding such a nice picture where you can see the ground reaction forces. This is the ankle joint center, knee joint center, hip joint center, and various types of muscle forces and joint reaction forces. Also angles in the movement. So everything can be measured and calculated, and you can see the role of the markers to define the human body as a rigid body, okay, and rigid consisting of rigid links. But that is used for the calculation of muscle forces and joint reaction forces. So please refer to our GAN course on orthopedic biomechanics, implants, and biomaterials, and refer to the lecture on gait analysis by Professor Nico Wertenscott. So this is available. I will just try to play that lecture. So thank you for listening to this brief lecture, which is a summary of the essential features of gait analysis. You are free to sort of do your online research on this subject and come up with a technical write-up on gait analysis as assignment 1. Okay, I will just briefly play the video. Just a moment. Okay, any questions at this instant?
So can we get a time extension for the assignment?
Why?
So because it's a very research-based assignment, and like it would be better if we can get time till Sunday. The weekend we'll have for the assignment.
Yes, sir. Please allow us to have the weekend.
Yes, sir. Yes, sir.
Sir, for many of us, this is the first lecture because we had not registered last week. So
Yeah,
if you
that's
can
got.
give some.
Yeah, so you want this assignment till Sunday, okay? Sunday night. Hello?
Yes, sir.
Okay, then I have to revise this. But see, one thing, if you are honest about your efforts towards writing this up, the students must be honest. Copying is strictly prohibited, okay? Now, we cannot, you people are senior students and we cannot go do this policeman job at this age with you, okay? So you are expected to generate your own report, okay? Based on your, because unless you do that, you don't learn the subject. Simply copying from your classmates will not help in learning the subjects. Okay, so special credit will be given for independent reports rather than clubbed reports. Okay, clubbed reports will be considered as copying. So I am yes.
So this is Swaraj. Actually, I joined the team today only, and I'm unable to access that assignment. It is saying you are not added to that assignment.
Okay, I will reload the assignment again. But you should. I will also send you the a separate email to all the registered students. But you have to submit the assignments here. So if you are registered in this course within the teams, you should get the assignment. Why not?
Sir, like I've also mailed you. You sent me the link. I joined it through the link today only, and now when I clicked on that assignment, it was saying that.
Yeah, it will come eventually. I will reload it after the class because I have to change the deadline anyway. Okay?
Okay, sir. Okay. If I will face any issue again, then I will send you a separate mail. Will that be okay?
No, there is no issue. There cannot be any other issue. Let me stop recording. Yeah.
All right.